welcome to my YouTube channel. Today we will learn the formal representations of NFA and DFA. When we say formal representation, we mean the 5-tuple representation. It provides a clear mathematical framework for defining the components and behavior of this automata. Let's write them. For DFA, we are writing it like this: Q for states, sigma for alphabets, delta function, transition function, which is represented by delta, Q0 for the initial state, and F, which is a set of final states. And when it comes to NFA, we can write it as follows. It is also a 5 tuples. Q for initial state as well, Again, the alphabet. The only difference is the transition function, which is represented by delta. Again, for the initial state, we write Q0, and for the set of final states, we write F. So you can see that the only difference between NFA's and DFA's formal representation is the delta, which stands for the transition function. Let's try to understand each component with an example. So this is our example. The left one is a DFA and the right one is an NFA. We will find their 5 tuples representation. Q stands for the set of states. So for DFA, Q is Q0 and Q1, and for NFA, Q is Q0, Q1, and Q2. The next notation is sigma. It stands for the alphabet. This is a finite set of symbols that the automaton can read as input. When we look for DFA, it takes 1 and 0 as an input. That means sigma should be 0 and 1 in DFA. When it comes to NFA, it takes A and B as an input. So sigma is A and B for NFA. The next notation is the delta. It is shown in DFA like that, and in NFA like that, and it is called delta. It stands for the transition function. For DFA, delta is a function which takes current state and input as an argument. It takes current state and input, which is alphabet, as an argument, and it gives the next state as an output. This one is the current state, and this one here is the output, next state. In our example, let's try to write one transition. Okay. When we are in Q0 and we take 0 as an input, we will go to Q1. When we are in Q1 and when we take 1, let's say, we will stay in Q1. Why? Because there is a self loop when it takes 1 as an input. So it continues like that for every transition. When it comes to NFA, let's write delta formally. Again, it takes the current state as well as the input Don't forget that NFA also takes empty string as an input, so we should write it. And it gives multiple next states, which we should show it like that. It's a representation of power set. Let's write it with another color. Power set of Q. Let's write some sample transitions from our example. Let's say when we are at Q0 and when we take A as an input, what happens? It goes to Q1, but we should write it as a set. It can include more than one state. For example, when we are at Q2 and when we take A as an input, there are more than one possible state. Let's see. We can go to Q0 as well as we can stay at Q2. Q0 and we can stay at Q2 as well. And it continues like that for every transition. The next notation is Q0, which stands for the initial state, starting state. For DFA, Q0 is basically Q0 because our initial state is Q0. And Q0 is an element of the set of Q, which is the set of all states. Also, for NFA, the initial state is also Q0, so we will write Q0, and it's also an element of Q for NFA. The final notation is F, which stands for the final states. The important thing is this is a set. However, this is just one state. For DFA, it only includes Q1. So, for DFA, F is a set which includes Q1. And for NFA, F is a set which includes Q2. So, now that we have found each piece of 5 tuples notation, we can write the final representations. Let's write them. So we have found 5 tuple representations for DFA and NFA. And this is all for today's lecture. In the next lecture, we will explain the pumping lemma. I hope that you have enjoyed watching this video. See you in the next lecture.